This video is going to go over how to find the expected value and then also variation and standard deviation of a discrete random variable distribution. I'm going to show you an example kind of with like the long version of it, and then I will also show you how to do this in StatCrunch. So expected value is also known as like the long-term average or mean. That's because we would expect this number if you were to do the experiment over and over and over again. There are some more information as to why this is the case. But when we find the expected value, you are also finding the mean. In order to do that for a random variable, you need to multiply each value of the random variable by its probability and then add the products, meaning the mean is the sum of x times its probability. Also, we can find the variance, sigma squared, by adding up the difference of each x value minus the mean times its probability. And then I'll find the standard deviation by taking the square root of the variance. So let's say that a child psychologist is wanting to know the number of times a newborn baby cries and wakes up its mother after midnight. There's a random sample of 50 mothers, and X is the number of times that the mom wakes up after midnight. Number of times per week, not per night, but the number of times per week that this happens between 0 and 5 is in our data set. So if I want to find the expected number, that's the same thing as finding the mean. So I'm going to multiply 0 by 2 over 50 plus 1 times 11 over 50 plus 2 times 23 over 50 plus 3 times 9 over 50, 4 times 4 over 50, and 5 times 1 over 50. All right, I'm going to just use a 4-function calculator for this. The nice thing about dividing or multiplying by 0 is this one just goes away. 1 times 11 over 50 is 0.22. 2 times 23 divided by 50 is 0.92. 3 times 9, 27 over 50 is 0.45. 4 times 4, 16 over 50 is 0.32. And then 5 over 50 should be at 0.1. And so again, I'm trying to figure out the average number of times per week Okay, 2.1 times per week. All right, if I want to try to figure out the variance, I'm going to show you how to do this with a couple of examples. So I'm going to do 0 minus 2.1 squared, and then I need to weight that difference times the probability of that happening, okay? And you would do this for all of these here. All right, well, it already took me long enough to do this by hand when I really didn't need to. So I'm really not going to do this one by hand. It is good to show one example to be like, I understand that this is the equation that I would use. But I'm going to use StatCrunch in order to do this. So let me pull that up, and I'm going to split my screen as well. All right, so once you do have StatCrunch up, you're going to put your X values in one column. And then you do have two options here. You could put this in as a rounded percent, or you can actually just put in the frequency, because a probability distribution for a discrete random variable is really a relative frequency distribution. So you could just put in the frequencies and you would be just fine. All right, so I'm going to go to Stats, Summary Statistics of Grouped and Binned Data. My bins are in variable 1 with my counts in variable 2. And I want to find the mean, the variance, and go ahead and find the standard deviation. So you can see we found the mean. Perfect. That was great. It calculated my variance for me. Now, the units on variance, because we're squaring, end up being like times per week squared, which isn't the right units. So that's why standard deviation is a better calculation to look at. And I went a little bit further, but then this gets us back to times per week. So an average 2 nights a week, kind of plus or minus 1. Okay, so you should expect to kind of be somewhere in this range. And if you look at our probabilities, like that makes a lot of sense that that's where our peak is. And so that's what our probability distribution would follow, and then some context there. All right, here's another example for us to look at. Suppose that you have a game with a biased coin. You play each game by tossing the coin once. Heads is 2/3 of the time and tails is 1/3 of the time. If you get a heads, then you pay $6. But if you get a tails, then you win $10. If you play this game, will you come out ahead? So let's think about this. In this case, X is really the amount of money won. Where little x is two values. If you pay $6, then you have lost $6, or you can win. And those are really the only two outcomes of X. So if you toss a heads, then you have to lose $6, versus a tails means that you win $10. So we would have that our mean is equal to -6 times 2/3 plus 10 times 1/3. You could do this maybe without a calculator, or you could do this with a calculator. It doesn't really matter. So your expected winnings over time is -2/3, or we could say you should expect to win 67 cents. Sorry, negative 67 cents, which really means we wouldn't win, right? We would lose 67 cents over time. And that's just another example of how to use expected value with a probability distribution in order to figure out your long-term frequencies or your long-term expected value.